Hi, today I'll be going over the solution of longest valid parentheses. So I'm going to go over the solution using this example. So the first thing is we're going to scan this string going forward. So we're going to go forward and scan the string, and we're going to declare two counters to keep track of how many open parentheses we have and how many closing parentheses we have. So I'm going to declare a counter open, I'm going to initialize it to 0, and closing, and I'll initialize that to 0 as well. So when you're moving forward, invalid parentheses moving forward is when closing parentheses is greater than opening parentheses. So for example, let's look at this parentheses. This is a closing parentheses, and if I count how many closing parentheses I've seen so far, it would be closing parentheses here would be 1, and opening parentheses would be 0. So I know that this is an invalid parentheses, and there's no opening parentheses right in front of it, so this is immediately invalid. And when that happens is we're just gonna reset our counters to 0 every time we encounter invalid parentheses. So invalid parentheses when moving forward is when closing parentheses is greater than opening parentheses. So when that happens, we'll reset our counters to 0. So of course, we also have to keep track of the maximum length. So we're going to have a variable called max length, which will keep track of when we have valid parentheses. So we have valid parentheses when opening parentheses equals closing parentheses. So update max length when open equals close. So if the current max length is less than the max length when open equals close, we'll update max length. So let's just start. So I'm going to scan this moving forward and increment my counters. Every time I see an open parentheses, increment it. If I see a closing parentheses, I'll increment that. So let's do it. So this is a closing parentheses, so I'm going to increment close. But this is invalid parentheses when moving forward, because close is greater than open, so I'm going to reset it to 0. Move forward. Okay, this is an opening parentheses, increment. Opening parentheses again. Move forward. Closing parentheses, increment. Opening parentheses. Closing parentheses. Opening parentheses, closing parentheses, and closing parentheses. So at this point, open parentheses equals closing parentheses. So basically from here to here, we encountered valid parentheses. So because these are equal, we're going to update our max length if it's greater than our current max length. So our current max length is 0. So we're going to update max length to being open plus close, which would be 4 plus 4. So open plus close, which is just 4 plus 4, which is 8. So our current max length, I'm going to write it up top, is 8. Okay, so we're going to move forward, closing parentheses, increment. Okay, now I'm going to reset these to 0. Now we're at the back of the string, so let's scan backwards. Now when going backwards, invalid parentheses is when open parentheses is greater than the amount of closing parentheses. So invalid parentheses when moving backwards is when open parentheses is greater than the count of closing parentheses. We're going to reset our counters to 0. So let's go backwards. This is a closing parentheses. We're going to increment, closing, increment, closing, increment. This is an opening parentheses, so we're going to increment opening. This is closing. This is open. close, open, open, and closing parentheses. So open parentheses didn't equal closing parentheses at any point, so our max length will still be 8. And then at the very end, we're just going to return our max length. So return max length, and in this case, it will be 8. So it's important to note in this problem what is invalid parentheses moving forward and what is invalid parentheses moving backwards. Okay, so now I'm going to just code this out. So I'm going to initialize my counters up top, so open, close, and I'm going to declare max length to 0. Now I'm going to scan forward. So if s of I equals open parentheses, I'm going to increment my open counter. Else, because we only have open and close parentheses, so we could just write else, but to make it more obvious, I'm just going to write if s of I equals closing parentheses. I'm going to increment close. Okay, so once we encounter valid parentheses, which is when open equals close, I'm going to update the max length. So max.max between the current max length and open plus close. Else if this is the case when we encounter invalid parentheses, so this if statement is for valid parentheses, else if will be for the invalid parentheses. Moving forward is when close is greater than open, right? Because right over here, this close would be 1, and open would be 0, and this is invalid because we don't have an open parentheses in front of it. So that's what is would be considered invalid moving forward. So else if close is greater than open, I'm going to set my counters back to 0. Okay, so that's scanning moving forward. Now let's scan moving backwards. So I'm going to reset my counters to 0 because I'm starting anew. I'm starting from backwards, moving forwards now. So okay, and same thing as before. If I see an open open parentheses, I'm just going to increment my open counter. If I see a closing parentheses, I'll just increment my closing counter. Okay, so we have a set of valid parentheses once again, if open equals close. So we're going to update max length if needed. So math.max, the current max length, and open plus close. Now, moving backwards, else if, so if we have valid parentheses, consecutive valid parentheses, if we don't have valid parentheses, at any point it breaks what is considered a valid parentheses, we're going to reset our counters to 0. So moving backwards, invalid parentheses would be when open is greater than close. And I'm just going to set my counters back to 0. Okay. And then at the very end, I'm just going to return max length. Okay, so I'm going to run this. Oh. Submit. Okay, so I'm going to go over the time and space complexity. So the time complexity of this would be, so we're doing one scan forward, and then after that is done, we're doing one scan backwards. So that would be O of 2n, but we can drop the constant and just simplify it to O of n. So the time complexity would be O of n. The space complexity would just be O of 1. So yeah, that's the explanation of the solution for longest valid parentheses. I hope this helped, and thank you so much for watching.